Hi guys, it's Andrew here from Get Into Game Dev. I've just finished up recording a session for an upcoming course that I'm developing on intermediate Pygame development. It's a follow-up from my Sugar Smash course, and I felt like this session went fun, so I'm just going to pop it up as a little preview, little ad for my upcoming course, which is still in development. Yeah, hope you enjoy. So we can read and write text files. Let's take things up a notch by looking at images. The goal of this session is to read an image from a file, apply a few basic transformations, and then blit it on the screen. We'll also be looking at taking screenshots. So let's get into it. So here we are. If you go and download the code for this whole course, head to folder number 2, images, and then the start point, the start folder. We have this graphics folder, and inside this graphics folder, we can get rid of that. That's fine. Inside this graphics folder, we have this skeleton boy over here. So what I want to do is basically load this image in, do some transformations to it. Let's head back and we'll open all of this in Visual Studio Code or any development environment you want to use. And we might get a little message here saying select interpreter, so we'll go ahead and select the interpreter. And that should be fine. And let's get into it. So what do we have at the moment? This is almost the most basic Pygame environment we can have. It's just a simple loop which pretty much does nothing. So we set up Pygame, we initialize it. Again, this is covered in the Sugar Smash course if you're not familiar with initialization, Pygame or anything like that. But basically we just pass in the screen size and we go to set mode. See here it says, whoops, it says it's returning a surface. Now a surface is a custom class inside Pygame, and it basically is a whole bunch of pixels. It's just an array of pixel data, and there we have it. So we set up this loop. This loop will keep going forever and ever until a quit event, and that is basically the user clicking on the X. In that instance, this while loop will exit because running is set to false. So what we do every time is we fill the screen with the background color, and then we flip the screen. So if we run this right now, it's filled with that background color defined over here, mostly blue. And when we hit escape, that is the quit event. So the first thing I want to do is I want to load an image. So we'll just load this here. And the way we load things is we have Pygame, and then there's an image module inside that, and then the load function. And we need a file name. Okay, no worries. So we'll just pop over. We have the folder graphics and then skeleton.png. So we'll put in here graphics skeleton.png. Okay. Now it says that this returns a surface, so we'll need to store the result into a variable. Let's just call this image. And there's another thing we need to do. It's a good idea to convert this surface into the native surface for the Windows format or the windowing environment. And this just speeds up the blitting later on when we draw it to our screen. So see, we have two functions, convert and convert alpha. Convert is just the regular, is what it says, and convert alpha is for images which have any sort of alpha component. That's fine, we can just convert that. Now, let's do this. We have screen surface, we fill that, and then we want to blit onto that. So the way this works is we're blitting one surface onto another. So let's blit the image. And we also want to, what is it? We look here, we have source, which is the thing that we're blitting onto it. the thing that we're taking the data from to blit onto the screen. And this does not have a default value, so we need to specify something there. Then we have destination, and this is the region into which we are blitting, which is either a tuple of integers specifying the top left corner, or it could be a Pygame rect structure, which is basically a more descriptive way of describing where we want to blit. But this doesn't have a default value either, so we need to specify a destination. And then we have area, and this area is if we only want to blit, say, some of the source. But this does actually have a default value with this equal sign, and this specifies that we actually don't need to put anything in here. Similarly, for special flags, this has a default value. Doesn't say what it is, but that's fine. So we don't need to specify that. So the point is, let's specify the top left corner. So I'm going to, where we put this? Let's specify this here. So we'll say, it doesn't matter. Let's just go completely in the center. So 320 across, 240 down, and specify that there. Okay, so let's give this a shot. Very interesting. So first of all, see that the top left corner is in fact in the center of the screen. But there's the issue that the image is really big and it's too big for the screen. So we're going to have to apply a transformation. Probably a good way to specify this is to specify ahead of time what the sprite size should be. And I'm just going to come up with this off the top of my head. So double the height compared to the width. That's fine. Okay, so what I want to do is I want to make, I want to scale this, but let's say I don't want to touch the original image. It's common practice to load an image and then take a copy of that with transformations applied so that we're not messing with the original image. That could, I mean, it's not the worst idea, but if we apply the transformations in place, they're non-reversible. So it's a good idea to have the original data. So I'm going to call this transformed image. And the way we apply this is we go into the Pygame library, if I can speak. There's a transform module inside there, and I want to scale. So if we look at this, the first argument we take is a surface. That's a surface that we want to scale. So we're going to scale image. The next is the size, and that's where we can put in this sprite size that we specified. Then destination surface. Now see, this does return a surface, and I guess we also have the option of, instead of using the return value, passing in a third argument, which is modified in place, but it has a default value of none, so let's just not even think about it. So let's take that transformed image and blit that onto the screen. And there we have it. Now we have the size. It's a little it's a little off. We could probably change the position a little bit. As a matter of fact, let's do that now. So let's go. Let's put the skeleton right on the bottom. So if the top left is at a height of 480, that will be right at the bottom of the screen. Then we will subtract the skeleton's height from that. I could be a little neater with this, but this is fine. And there we have it. Skeleton is on the ground. Okay, so what are some other transformations we can apply? Well, let's spin the skeleton around. In order to do that, I'll just specify a variable called t, or time. So parameter there. And I'm just going to increment this every frame. So what we'll do is increase, time by a little bit, and then modulus under 360, just so that after a full revolution it comes back. So I'm going to apply a transformation stack. So see, we've applied one transformation. If we go Pygame transform rotate, then we want to rotate the transformed image sprite. We want to, for the angle, just go T, and this returns a surface. So we can save that there. Give that a go. Oh, okay, so it's spinning. And yeah, we could control the timing a little better. We can make a clock. But the big thing I want to look at is see that as the image spins around, the rectangle around it is resized. And because the anchor typically is the top left corner, then results are unpredictable. Of course, this would look better if we had an alpha channel instead of a white channel. But then the skeleton would still be spinning around like this. We just wouldn't be able to visualize the rectangle. So what we want to do is recenter the image after spinning it around. Things tend to spin around their center, so here's what we can do instead. So we rotate this, and then get the rectangle of that. And the way we do that is we take the transformed image and then get the rectangle. And we'll just leave that there for now. And then instead of the skeleton position, we'll pass in the transformed rectangle. Okay, so this makes sense. We no longer are setting the top left corner, but we still have the same issue. Actually, we're almost there. So what we can do is we can pass in a keyword argument. So we get the rectangle, and then we set the center to a certain value. We go 320, 480 minus 256. That's a little better. It's not quite on the bottom, and the reason is originally we were looking at the top left, which would have a height of 256, but if we're looking at a center, the center has a height of 128, so we'll just pass in half of that. And there you can see, yep, the skeleton is spinning around in place. So this is sort of an esoteric thing when we do it for the first time, so I'll step through it again. What we did is we rotated the image and then we recentered the image. So we specify, yep, I want to get the bounding box and center it around this coordinate. So that makes sure that things don't get weirdly shifted around. Of course, the white background looks weird, but if this was an alpha channel, it would look perfectly fine. So that's one sort of transformation. How about color? So I'm going to specify something else. I'm going to specify a tint color that I want to apply to the whole image. And I like to use sine and cosine when I'm animating or automating simple parameters, simply because they're repeating functions. So I'll import the math library, but I'm just using this to generate a tint color. So if I take 128 plus 127 times sine, well, math sine. Sine goes between negative to positive 1. So at one extreme, we would have 128 minus 127 is 1. At the other extreme, we'd have 128 plus 127, which is 255. And that's pretty good. I'm happy with that. So I'll just convert that to an integer. That will be the red component of my transformation of my color. And I'll just, yeah, why not? I'll just put 0 for the other components. So this is specifying the tint color that I want to apply to my image. How do we apply that? Well, what we do is we fill the image. So we go transformed image, fill, and then I'm going to say, okay, for the color, we'll put in tint. For the rectangle, we don't need anything, but in order to make sure that we're not just overwriting the data, I want to specify a special flag. And that special flag is if I go into the Pygame module, blend, and let's multiply. So as you can see, it's just modifying the red channel, and it's repeating. Actually looks pretty cool. I've got to be honest, looks pretty cool. There are other options. Let's go max. So see there, the white is already greater than the red, but then the black parts flash red. I don't know. I think this looks cool. So we're applying geometric transformations to images. We're applying per pixel transformations to blend the colors and things. I'm sure you can imagine in an RPG game, if a character gets hurt, you might want them to flash red. If they get poisoned, you might want them to flash green. Those are the major colors, right? Okay. But another thing we might want to do is take a screenshot. So let's have a look at that. I'm just going to add some other parameters here. Let's go screenshots taken is 0. This is just so that every time I make a new screenshot, I'll save it to a new file. Let's go here. So in the events, we'll go if the event type is a key down, event so basically if we hit the space. Now we want to save this. Now if you look back above, we have Pygame image load, and that returns a surface. So I guess maybe we'll go Pygame image save, and that takes a surface. Okay, so the surface we're going to take is our screen surface. We're going to save all the pixel contents of the screen surface, and then we have the file name. So for the file name, I'm going to use an F string. I'm going to make it screenshot. And then we'll insert the screenshots taken variable. So the first time it'll be screenshots 0, screenshots 1, screenshots 2, and so on. And then we'll just increase that screenshot count. Okay, cool. So give that a go. I go space, space, space. Okay, so I should have 3 screenshots. And if I look at my folder, yeah, I do. I have 3 screenshots. Now you may say, what is the benefit of taking a screenshot? Well, imagine you're playing Final Fantasy or Pokemon or something, and you walk along and then you trigger an event. It would be really good if we could take a screenshot, then read that screenshot back and apply post-processing effects to it. I know OpenGL, you can do that without taking screenshots, but this is Pygame, and I'm not doing OpenGL in this one. So yeah, hopefully that was fun. Learnt a few things. It's pretty cool. Pygame is cool. All right. See ya.